Okay, I want you to picture the sheer scale of a modern mining operation. We're talking about massive, sprawling infrastructure, thousands of employees on site, and literally billions of dollars in upfront capital investment. Now, imagine all of that grinding to an absolute dead halt. And not because of a sudden crash in commodity prices or, because the ore ran out, but due to the simple, stark lack of one fundamental resource: water. Really think about it. What actually happens when the well literally runs dry?
Well, welcome to the modern era of water wars, and let's dive right into this, because this isn't some distant dystopian sci-fi hypothetical we're talking about here. This is a current, rapidly escalating reality. We're looking at a global landscape right now where local communities, agriculture, and massive corporate mining entities are locked in this intense, high-stakes competition over incredibly finite water resources.
Water wars, mining operations in high-stress basins. To really dig into these operational risks for today's explainer, we're going to use a highly specific, very rigorous lens, the SASB Metals and Mining Sustainability Accounting Standard. This is the exact framework that major investors and corporations use to measure the cold, hard financial risks of environmental and social issues. We're going to stick strictly to the data and the actual disclosures demanded from the global mining industry. When you look at the actual text of this sustainability standard, you quickly realize it's demanding strict, quantitative disclosures around corporate water management. Take a look at metrics EM, MM 140A.1 and 148.2. It's not just politely asking for a vague sustainability pledge. No, it requires hard data on total water withdrawn, total water consumed, and critically, what percentage of that water comes from regions facing severe stress. It's literally translating environmental realities directly into measurable financial risk. To really grasp the gravity of this risk, we have to define our terms here. The standard forces companies to identify operations in locations with high or extremely high baseline water stress. And according to the World Resources Institute's aqueduct tool, which the standard specifically cites, this means locations where 40% to more than 80% of the available water is already spoken for. Just pause and think about that. That is a staggeringly severe environmental baseline. Imagine trying to run a ridiculously water-intensive mining operation in a region where virtually every single drop is already claimed by the locals or other industries.
The reporting also meticulously differentiates between water that is withdrawn and water that is consumed. And this distinction is huge. Withdrawn is just the total water taken from local sources, surface water, groundwater, municipal supplies. But consumed, that's the water that doesn't go back. It's the water that evaporates during processing or gets permanently incorporated into the product itself or is just moved to a completely different catchment area or dumped in the sea. It's the water permanently lost to that local, highly stressed environment.
So the crucial takeaway here is the domino effect that happens when scarcity truly hits. It triggers this massive, cascading financial fallout. If a mine simply cannot access the water it needs, right off the bat, it faces higher costs just to acquire it, maybe through insanely expensive desalination plants or massive recirculation tech. But worse than that, it faces regulatory curtailments. Governments step in, which leads directly to the suspension of operations and ultimately massive lost revenues. The entire operational lifeline just gets cut. But hey, the water wars aren't just about the sheer volume of water you're pulling out of the ground. Actually, it is equally about the fiercely contested regulatory battleground of water quality and contamination. Because the big question is, what happens to the water you do put back? And that brings us to a really vital number, metric EM140A2. This tracks the total number of incidents of non-compliance associated with water quality permits, standards, and regulations. And let me be clear, it doesn't just track minor oops, we missed a deadline paperwork errors. The scope of this disclosure specifically targets incidents resulting in formal enforcement actions by regulators. We are talking about serious violations, like the unauthorized discharge of hazardous substances or totally failing to meet pretreatment requirements. Because regulators aren't just out there checking for slightly murky water, they are actively hunting for specific, highly dangerous pollutants. We're talking arsenic, copper, lead, nickel, cyanide, and total suspended solids. If a mining operation gets sloppy and allows these heavy metals and toxic chemicals to breach regulatory limits and seep into the local watershed, the financial and reputational penalties are absolutely severe. And honestly, perhaps one of the most concerning water quality issues the entire industry faces is acid rock drainage. Mining entities are required to explicitly disclose the percentage of their sites facing this specific threat. Acid rock drainage is this highly toxic process where surface or shallow groundwater hits coal or mineral mining overburden, becomes contaminated with heavy metals, and turns highly acidic. Companies have to report if this toxic runoff is predicted to occur through their computer simulations, if they're actively trying to mitigate it, like by covering up sulfate-bearing minerals, or if they're stuck currently treating and remediating acidic water that's already discharging from the mine. All right, now we need to shift our explainer's focus to the human element. Because obviously, water scarcity and contamination don't just happen in a vacuum. They happen in places where people actually live. And significant socioeconomic friction inevitably arises when massive mining entities and local communities collide over the exact same finite resources. We are looking at a very stark juxtaposition here. On one side, you have the corporate needs required just to survive, continuous access to energy and water, obtaining operating permits, securing leases without disruption. But on the other side, the standard requires tracking fundamental community rights and interests. Environmental rights like clean local air and water, economic rights like agricultural land, social rights like food security and local livelihoods. When a mine exploits a community's resources without providing proportional, tangible benefits, that tension is going to boil over. It's practically guaranteed. And how exactly does that community tension show up on a corporate balance sheet? Take a look at metric IMMM210B2. It tracks the total number and duration of what the industry calls non-technical delays, measured in days idle. So if a local community protests, or stakeholders resist, or there's intense political interference because a mine is depleting local water, the mine gets shut down. Those protests directly translate into massive financial hits. At the end of the day, an idle mine is a mine that is absolutely bleeding money. So how in the world is a modern mining operation expected to handle this? Well, the standard requires them to openly discuss their processes for mitigating these deep community risks. And this isn't just fluffy PR. It's about operational survival. Companies have to disclose if they are using social impact assessments to evaluate risk, if they're conducting ongoing stakeholder engagement, creating shared value projects that provide a real quantifiable benefits to the community, and aligning with rigorous global benchmarks like the International Finance Corporation's performance standards. Okay, but what happens when the tension between daily operations, the local community, and water management completely breaks down? We have to escalate to the final and, frankly, most terrifying risk outlined in the standard: the catastrophic failure of tailings storage facilities. Tailings are the massive, almost incomprehensible volumes of waste left over after the valuable minerals have been separated from the ore, and they're usually stored as a wet slurry in giant engineered impoundments. Make no mistake, dam failures at these facilities release significant volumes of toxic waste streams and highly harmful materials directly into the environment. It is a literal existential threat. A failure of this magnitude doesn't just damage an ecosystem. It threatens human livelihoods, completely devastates local economies, and can entirely obliterate a company's fundamental social license to operate, leading to staggering financial losses and remediation obligations that can last for generations. Because of this monumental risk, the standard demands absolute, unwavering transparency. Companies must disclose an exhaustive, point-by-point inventory of every single tailings facility they operate. We're talking the facility name, whether it's active or closed, the exact construction method used, like whether it's an upstream or downstream build, its maximum permitted storage capacity, its hazard consequence classification, and, critically, if any recent independent reviews uncovered material findings regarding its safety. And to prevent these worst-case scenario catastrophes, companies have to implement incredibly strict governance frameworks. They need a designated engineer of record conducting regular performance reviews. They must undergo independent technical reviews by parties who were not involved in the original design. If safety concerns pop up, they are required to implement mitigation measures to reduce the risk to a LARP, meaning as low as reasonably practicable. And finally, they absolutely must have site-specific emergency preparedness and response plans to coordinate with local first responders if the worst does actually happen. Which really brings us to the ultimate question for this explainer. As environmental baselines shift and regions become increasingly stressed, can the global mining industry actually survive the coming water crisis? Or will their operational lifeline just dry up? As we've seen through the meticulous lens of the SASB standard, it's not just about finding the minerals in the ground anymore. It's about navigating the immense financial, environmental, and social tightrope of water scarcity and toxic waste management. It definitely leaves you wanting to scrutinize those corporate sustainability disclosures a whole lot closer, doesn't it?